Okay, thanks. So this ought to be minus 1. Okay, I actually just formulated with some quadratic equation on the board. All right, this ought to be minus 1. So we have, what are the factors now? 2 and 1. Right? We're going to get positive, so we get 2a and minus a. I'm doing factorization, you can use formula method, your choice. So you get 2a, a plus 1, minus 1, a plus 1. Hello?
Yep.
So on one hand, we have a plus 1. On the other hand, we have 2a minus 1. So that we get a plus 1 is equal to 0. I'm only taking my time to show so many steps to justify what I'm doing. Then here, I can write directly a is equal to 1 over 2. Am I making sense?
Yeah.
So how you get this is up to you. Formula method or whatever. But whatever you do, please don't write everything in one straight line. That's a very unacceptable way of presenting your work. And some of you, you are working your solution, you are going this way. What is all this diagonal way of writing? Come on. Start on the left each time. Present a neat page. Okay, so with this, I can now say, oh, recall that sine x is equal to a. Then I have two equations. So in this case, my sine x is equal to -1. In this case, my sine x is equal to 1 over 2. In your unit circle, this is where, is it the x coordinate minus 1 or y coordinate minus 1? When the y coordinate is minus 1, which means at the bottom, right? And that is only one possibility. And that is 3 pi over 2. So here, x is equal to 3 pi over 2. Now for here, when you have 1 over 2, so it's the 30, 60 ones, right?
It would be
So that's sine. Sine is x or y.
y.
Sine is also y. So you're having something like this when you have sine, so 30, right?
I would say.
But for the y, isn't it?
Yeah.
So which means the reflection will be here, along the y-axis. Is that not? So one will be
Pi over 6.
pi over 6, and the other will be
5
5 pi over 6. So this is x is equal to pi over 6. The other will be 5 pi over 6. If you don't know what to do, the first one is pi over 6. You already know the reflection is here. This angle, we also have the reflection here. So if this is pi over 6, this is also pi over 6. But the angle you are looking for is with respect to the origin. So one of them is this, the other will be this. So which means when you get your pi over 6, the other will be the entire straight line, which is pi, minus the pi over 6. And that gives you this. If you don't know how to read it, 1, 2, 3. But I think the reading is easier because you just have to count. 1, 2, no, 0, 1, 2, 3, and so on. Does that make sense? Because your calculator wouldn't give you everything. Understand? So, for your book, the question actually starts from here. For the worksheet that I've given you, the question starts from here. But for the exam, don't expect the question to start from here. Expect the question to start from here. Okay? So I will want you to show me this. So basically, even for this step, I will expect you to say because, not therefore. Because cos squared x is equal to 1 minus sine squared x. That's the reason for this. So you write it on that line. Or you can say since, understand? Then you continue your work. You see, I'm just continuing the same thing. Again, for this, you can go directly into writing. Some people that wouldn't go this way, from this step, they will probably do sine x plus 1 into bracket 2 sine x minus 1 is equal to 0. Some people will probably do that. It's fine. Then you say either sine x plus 1 is equal to 0, which will give you this, or this is equal to 0, which will give you that. Your choice. But whatever you do, justify what you're doing. Okay? I have about maybe 4 minutes, so let me play for you the solution in the book. Only this one.
In this example, we consider trigonometric equations whose form is also a quadratic. In part A, the equation is a quadratic equation in the variable sine x. Compare it with this form, where sine x has been replaced by x. We can solve the quadratic equation by factorization to find sine x. We first take out the common factor sine x.
Understand?
By the null factor law, one of these factors must be 0. So, either sine x equals 0 or 2 sine x plus 1 is 0, in which case sine x is minus 1/2. You might notice that, like in previous examples, the solutions we are finding are angles in a known trigonometric ratio. We can therefore use the unit circle. We need to locate the points with y-coordinates 0 and those with y-coordinates minus 1/2. The angles corresponding to y-coordinate 0 are 0, pi, and 2 pi. Do not forget the angle 2 pi at the endpoint of the domain. The angles corresponding to y-coordinate minus 1/2 are 7 pi on 6 and 11 pi on 6. We therefore have 5 solutions for x. In part B, the equation is a quadratic equation in the variable cos x. Compare it with this form, where cos x has been replaced by x. We can solve the quadratic equation by factorization to find cos x. We write 2 cos squared x as 2 cos x times cos x. Then find two constants with product minus 1 and which will give the correct middle term cos x. The left-hand side is now a product of two factors. By the null factor law, one of these factors must be 0. So either 2 cos x minus 1 is 0, in which case cos x is a half, or cos x plus 1 is 0, in which case cos x is minus 1. We draw unit circle diagrams for each possible value of cos x. We locate the points with x-coordinates a half and the points with x-coordinate minus 1. On the domain 0 to 2 pi, the solutions are pi on 3, pi, and 5 pi on 3.
And that's it. Okay. Does this make sense? So it's the same thing that we've talked about. Okay? Thank you very much, ladies and gentlemen. This will be the last official class that we have as Form 5, as AA students, and as a group. Our class on Saturday will be strictly on revision, especially on the question that I'm going to hand in either today or tomorrow. And those are the ones we will focus on Saturday, specifically for the exam. And I will encourage us to also organize a Zoom over the weekend where we can come around and discuss the questions in that worksheet as well. I need you to talk among yourselves, either in the group, and decide whether Saturday or Sunday will be better and what time you would like to have it. Yes, ma'am. Quickly, please.
Do we need to submit all the worksheets?
No. If you bring it, I'll find time to mark it and give it back to you. But of course, they are not part of your grade because I'm finalizing my term, whatever, tomorrow anyway. Guys, please, I need you to talk in your groups and decide what time you want to have this Zoom this weekend. Because I need to meet with the, I think we agreed to do together. So you guys can be in the room.
We'll do it next weekend.
Oh, okay. Next weekend is better
Yeah,
then.
next weekend is much better.
All right, okay. We talk in the week. Okay? Good luck from Monday. Bye-bye.